I wanted to share a Terraform deployment that I've been working on that will configure an Azure Virtual Desktop environment and have it running within 5 to 10 minutes. Um, to get this going, there's a couple things that you want to have ahead of time. Um, an existing subscription and an existing entry tenant, which should all be part of your Azure environment, and then decide on the location that you want. So what this will do is it will deploy an AVD workspace with one or more host pools, each of those host pools having one or more application groups. Those application groups having applications with inside them that are published to the end users. And then, group assignment happens per application group here as well. Some other things that it also deploys are the storage account, premium Azure file storage. It can be either Entra Kerberos or Active Directory joint storage account. It can deploy multiple shares on that storage account as defined in the variables. And it will also deploy an image gallery to store your images, an image definition of those images, some Azure policies to configure the VMs for VM updates, Azure monitoring agent, data collection rules, and some other ancillary services for AVD. And it will also utilize Packer to create the images. That way, with Terraform being state-based, all of the changing parts, regularly changing parts, are outside of the Terraform configuration, including the session hosts. And then we actually use Azure Automation runbooks to create the session hosts. It will join them to the domain and also add them to the host pool. I have those split out as two separate calls. The idea being that if you're using Intune for configuring and installing your applications on a session host, you won't want to add those to the pool right away until they've gotten the policies, installed the software, and you're verified that they are good to go. Um, so a lot gets deployed, and it takes, I don't know, around 5 minutes for the actual Terraform deployment, maybe another 5 minutes for Packer to build an image, and then maybe 3 to 5 minutes for Azure Automation Runbook to deploy a VM and add it to the host pool. We're going to go through all that here. So really, the idea is that this can be checked out from a Git repo, and the only thing that needs to be edited, assuming this is a greenfield environment, is the Terraform.tf file, which is basically the variable constructs for everything that's going to get built. And that's what I have on my screen here. As we talked about, you want to set your location where everything's going to be deployed at. This is going to be the entry tenant, and then this is the Azure subscription ID. Everything will be deployed to one resource group. So everything in this block here will actually get deployed one time. So there'll be one resource group, name this. There will be one VNet with this IP space, the name of the VNet, DNS servers for the VNet, and then also the subnet name within the VNet. It assumes that the subnet is going to be the same size as the VNet, but that can also be changed. So this defines the automation runbooks that we have. Those are all already pre-built PowerShell scripts in here. So everything in this block will map to one of these files. And then basically, if it has webhook equals true, it's going to create a webhook for it. And then if it has enabled equals true or just not defined, true being the default value, it will create the runbook. So in this example, it's not going to create a separate add host to domain runbook. That's already been incorporated into the create host. So just as an example of what can be done here, I've set that to false, showing that that Azure Automation runbook will not be created. That's what we have under those runbooks. And then, so the host groups, the dynamic host groups are entry groups that would be created and used to collect the session hosts into a particular group based on a filter substring. So what this does is it creates an extra dynamic group that will be called whatever set at this variable. So like we could call it AVD hosts. And the group filter will be anything that contains, let's say we're going to name our AVDs AVD dash, whatever. So any host matching AVD dash in the system name is going to be put in this group. And then that's useful for Intune policy deployment, software deployment, etc. So that can be set here. You could also create them ahead of time and then have the Intune policies already configured and ready to go with that group, and then just not create this. So this is the meat of what gets deployed. It will create one workspace, N number of host pools, Y number of application groups, Z number of published applications. So basically it's a nested type of variable assignment. All these host pools will be linked to this AVD workspace. And then this host pool is going to have enter auth type for the hosts, custom RDP properties for the host pool, load balancer type, breadth, etc. A scaling plan configured for it. A scaling plan will get created, so these need to be created per host pool. You can't just create one for one host pool and reuse them. Just the logic isn't there to do that. So every time you define a scaling plan, it will get created. So just make sure that the name is different here for each host pool. So the scaling plan, setting up an AVD scaling plan, which it only controls powering on and powering off of the VMs. It doesn't actually create or destroy them for you. It only does power on, power off. 730, we're going to go breadth first, and that will allow sessions to be distributed evenly across the host, basically to handle logon storms. Depth first, sessions on one host until it's about 60-70% full, then I'll move on to the next host. So it just kind of configures all that stuff. And then, do we want to force log off users? It's set to false. If users are still logged on, when they're trying to scale down, they won't be automatically logged off. So this host pool will have two application groups set to it. I've had to reuse group names that I'm already a member of. Normally you would, create new groups for these, have them already created within Entra or synced from on-prem, and then assign those to those application groups. So this application group will deploy Chrome, will deploy Edge within this host pool and within this application group. And then this second application group, it's going to be, again, a remote app application group rather than full desktop. And then you just provide the different applications that you want here. Obviously this one's named Chrome, probably want to change it to SAP. And then this one is iWidget. These names right here are really inconsequential. They don't actually change what's deployed. All that matters are these fields right here. Third app group, and this is the full desktop. So this is what we'll actually be seeing. So when you launch it, you get start menu and everything else like you're logging onto the remote desktop rather than just an application stream to your interface. Second host pool will be created. This one is going to be Active Directory authentication type, and depth first. Again, we're going to assign a scaling plan with a different name, similar settings there. If you uncomment this, it'll have similar application groups as well. We're actually not going to run from this file. This just shows that you could actually have an application group with no applications if you wanted to comment out this much here. And that way you have an empty application group that you could utilize later. So here we have the shared image gallery that's going to get created. This will hold all the different images. We're going to create one image name, image definition called image app1, and then a second one called image app2. If you're loading all your applications into the images ahead of time, you'd want separate images for each host pool that you're going to create so that they all have a consistent configuration. Here we define a maintenance definition. This is for Azure Update to when you want to patch the VMs, what patches you want to apply to them, so that way patching just happens automatically. Really define the name of it. In guest patch, meaning you're going to be patching the guest OS. We're going to be doing critical security and updates, so cumulative updates as well. It's gonna, for testing, we recur it every day. You might want to make that every 1 month. And then start time, you want to put the start time, maybe to like 10:30. That way it's not getting interrupted. This will create the storage account. Again, so you need groups for who's going to have SMB contributor role, SMB elevated contributor role, storage account name, and then it will create these two shares with this quota. It will be an Active Directory configured storage account. It's going to join to these domains. You have to actually create the computer object manually later, but this does the configuration on the Azure side of things to create that storage account. Key vault name. So we create a key vault to store the password that's used to join the domain when you want to run any of the create host Azure Automation blocks. It's built in there automatically to go out and get the secret, so you don't have to store the password in text anywhere. And then policy target locations, that is going to be some of these deploy Azure policies. What location do you want targeted for those policies? We do set the scope to the resource group, so that way it's not going to apply the policy to any resources that were intended. Again, this resource group should only be for AVD, objects and items related to any AVD deployment. At this point, we're going to go ahead and just run it. We're going to get the date and the time just to see how long it actually takes to deploy this. All right, and it's completed its deployment. It took about 10 minutes here this time. I've deployed it a handful of times. It's usually right around the 5 minutes or so. A little bit longer. It definitely was slower reading the resources in the beginning. For whatever reason, it took a little bit longer. So now that that's done, it gives us a bunch of output. And one of the things that I've configured it to do is to give us what the Packer configuration should be deploying the first image. So if you grab everything, so here's the Packer variables, you grab everything below it to that point, and then we'll bring up our Packer environment. So basically everything should be good to go with the exception, we've got to change this to only choose one of these two image definitions and then the version that we want. This could all be configured if you're to do some sort of like CI/CD pipeline to actually automatically populate those with things that have been in the past. But since Terraform doesn't really know about these, or maybe which one you want to use, because the image definition it creates two, but you only want to populate one image at a time. That way you can just easily deploy this and then have a new image going. So it's going to go through it, pulls in all the information that we're giving it, that we're using Azure to build this VM. It's going in the same subscription that we've been using. It's going to use Azure CLI auth rather than a managed identity. And then it's going to put it in the same resource group that we've been using, which is over here. Then the image version is going to be actually set at latest. So now if we go ahead and just run this, now that that file's been populated, it should go ahead and build the Packer image so that we can deploy a VM from it. All right, Packer is completed creating the image. It's just cleaning up the resources that it deployed in order to build the image. It creates a VM with a NIC and all that stuff so that it can log in and make changes to the OS as defined in the config, then turns it into an image and then stores it in a shared image gallery. So now that that's done, we're going to switch back. We're going to go to our Terraform output and get the webhook URLs uh, for create VM, and then also to add the host to the pool. So here's add host to the pool webhook. So we're going to put this in our script that will um, call that webhook. Basically, just an API call to the endpoint. We're going to give it the name of the host pool, the name of the resource group. The account ID is a managed identity that's going to actually do the work, and then the name of the VM that will be created at this point. And then we will do the same thing for the create VM. What we're going to do here Just grab the create host webhook URL and then go ahead and put it in that same script. All right, so we're setting a webhook URL here. And now we're setting the body payload to set basically provide all these variables to the Azure Automation runbook that's going to create the host. So again, this is a resource group name, host pool, the managed identity that is going to actually be running the Azure Automation account. It's going to go in this VNet and then this subnet, which are what's created in Azure. We're going to use this gallery image that we created as part of our Terraform, and then the actual version was created with the Packer deployment. So this host prefix, the hosts are going to be named demo-avd, and then the script will add -1-2, incrementally as new hosts are built. So that way you don't have to provide a new host name every time. You can provide the host prefix. The size of the VM, we bump this up for production, but just for testing, we're using a B2AS V2. The location that we're going to put this in the Azure region. This is a key vault name that we created with Terraform. And then the secret name in there is domain join password. It's actually not going to use this since we're not joining the domain. We are going to join it to Entra, so that's set to true. And again, these ones here would only be used if we're going to deploy it to a domain. So basically, it's going to set that variable and then call the webhook on Azure Automation. All right, so it created that job. So we're going to go ahead and pull up Azure here and take a look at that runbook and watch as it goes ahead to create the host. Now it's in the AVD automation account, and then under the runbooks, we have create host. And we can see this job here is starting. So we're just going to go ahead and watch the output, make sure everything goes through successfully here. All right, so one thing that I forgot, since this is a new deployment, this actual account ID is different. This was my previous deployment before I tore everything down and recreated it. So we're going to go back to our Terraform, look at our output, and it should give us that account ID that we need to use, which is right here, which is why that job failed. All right, so we'll go ahead and update our two scripts here. And then we will rerun the create VM script. We'll go to the next job that's running here. Refresh this. All right, now it shows that the job is running. It should start giving us some output as to what it's doing here anytime now. All right, so it's going to tell us what image it's using to actually deploy the VM. It's creating a VM configuration, which is basically just setting some parameters for the VM, and then it's actually creating the VM. This one takes a couple of minutes. Then when this is done, it should make it enter joined, and then after that, we should be able to add it to the pool with our other automation runbook. All right, so it looks like it is done creating the VM. It gives you the name here, local username, and it's joining to Entra. This could be configured to export the local username and password to like an Azure Key Vault for each VM that's created. But since most of these are joining to the domain or joining to Entra, don't really need those. And then hopefully that end user has labs configured so then the local admin password is just managed through that. So then once this is done, then we will add it to the pool. All right, looks like it's done joining it to Entra. Just going to wait until this says completed before we go ahead and move on. All right, it is now completed. Everything is done. It should show up in Entra. That's the VM name here. And just to pull this over, this is the VM that got created. These are the two items that got added as part of the Entra join. They're extensions of the VM that allows it to be logged in with Entra credentials and also do the Entra join. All right, now that that's done, we're going to take the VM name here and we're going to make sure that we have the right VM name, and we're going to run our automation runbook that is going to add it to the host pool. Just to kind of start from there, we can take a look at our Azure Virtual Desktop host pools, and we can see that the host pools, there's HP app 2, HP app 3. There are no machines in the host pool at this point. So if we look at this, it looks like we're going to add to HP app host pool, and then that's the name of the VM that we have, and then that's the updated account ID just to make sure they match. They do. Save that. We're going to go ahead and run that. All right, and it looks like it is currently running. So we'll take a look at here, take a look at the output and kind of see what it gives us here. So it's getting a registration token. So to add a host pool or add a host to a host pool, you need a host pool registration token. By default, one doesn't exist. So if it doesn't exist, the script will automatically create it for you and then get that value and add it to the host pool. So it's generating a new registration token, which obviously completed. Now it's adding it to the host pool. All right, now the job is completed. It should be added to the host pool. So let's take a look at our AVD host pool here. Looks like there's one machine. Currently can't connect. We just got to give it some time here. Configured and all that stuff. And then it should be good to go. All right, now that it's showing that it is in the can connect state, we should be able to actually connect to this. So right now we're showing, so this is for a different account, but the one that we want to look at here is for my Sentinel account here. So we're going to go ahead and refresh this feed. Hopefully we should get some applications that show up and be able to log into it. So we have Edge and we have a session desktop. For this one, we're going to do the session desktop and go ahead and log in. All right, now you can see we're getting logged on to the AVD session. I've got a full desktop available to me here once I get logged in. And then that is how you set up an AVD environment very quickly, very easily through using Terraform, Packer, Azure Automation runbooks. And then there we are. It's a little bit slow. It's because we're using the smaller B2AS VM, so it only has 2 CPU, 8 gigs memory. If we want to summarize everything that got deployed here, we can take a look at our resource group. There's 36 resources. There are a lot of sub resources. That's why Terraform, when it output, said there was 74, I think it was. But if we sort these by type of resource, we got our 4 application groups that were deployed. Automation account, we got our shared image gallery, we've got our data collection rule, we have got the disk for the actual VM. We've got our 2 host pools here. We've got our Packer image that was created. That's what actually gets uploaded to the shared image gallery. We've got our Key Vault. We've got our Log Analytics Workspace, maintenance configuration, managed identity, the network interfaces. We did create a private endpoint for that storage account. That's part of the deployment. So that way all traffic is private. Private DNS zone that points to that private endpoint. And then we got our runbooks, our host pool scaling plans, 2 storage accounts. This one is the boot diagnostics for the VM that was created. And then we've got our VM. We've got our VNet, our virtual network link, linking that DNS private zone to our VNet. And then our image application definitions, our shared image version, and our AVD workspace. Some other things that were also created as part of this that aren't necessarily apparent is some RBAC roles that were assigned. So at the subscription level, we will have contributor added to the subscription level, which we can see here is our AVD automation managed identity. We have got some permissions for virtual machine user login. This allows every group that was used to assign to an application group the ability to log in to the VMs that are deployed. These are defined right at the resource group. And then we should have a virtual machine power on, power off, which Right here, contributor for the AVD, that allows a scaling plan to work. That's just a built-in Microsoft service principle there. Deployed some Azure policies. So if we look at, we want to look at these 1, 2, 3, 4, 5 here, since they are the ones that are assigned to that resource group. So this will make sure that all VMs have a system aside managed identity that allows them to utilize Azure Update. Um, and this one configures them to periodically check for system updates. This sets the prerequisites for any of the updates on Azure virtual machines that need to be configured. This policy will ensure that the Azure monitoring agent is installed on all VMs. And then this data collection rule will make sure that all the session hosts or all the VMs that get deployed will have that data collection rule, which pulls in logs and stuff to fill out the metrics for the Azure Virtual Desktop. Take a look at the insights. Um, Normally, this would say you need to configure your session hosts in your workspace for data collection, but this is all done automatically. So we do see that we've got one monthly user. It's a $5 charge per monthly active user for AVD. So that's a good thing to be able to keep an eye on, connections and sessions, etc. So a lot of stuff there on the AVD side of things. So yeah, so if we look at the monitoring, there's the connection reliability. Um, any type of, there were no disconnects, so that's good. Connection diagnostics, we should have the one connection. This goes over utilization, how many sessions there are, how many cores, user per core summary. That's pretty good because you configure how many users per core you want before it starts scaling up and down. And the clients, type of client, so you can use a web client, you can use a Microsoft Remote Desktop client, and Mac has a client as well. Just all the monitoring information gets pulled in automatically. So that should be it. That kind of covers it. Obviously, if you have any questions, let me know. This is going to be really helpful for deploying out these AVD environments. I know we're going for our specialization later this year, which should help get us more business. And then if we can deploy these things in 30 minutes to an hour, not including blueprint design time, etc., that's going to really make a big difference on completing those projects.